All right, this is week 4 of Math 208, section 4.1, determining whether an ordered pair is a solution. So what does that mean to be a solution? So what you're going to do to determine whether these points are a solution of the system. So you've got this point here, you've got this point here. And in order to know if it's a solution, that point has to work for both lines. Now, I'm going to zoom in here, and you got to remember that the first value is the x, the second value is the y. So in this case, the b, the 2 is the x, and the 5 is the y, and in a, the 1 is the x, and the 6 is the y. And so what you're going to do is let's take 1, 6, and you're going to take x is 1, y is 6, and you're going to substitute it into both of these equations. And if 1, 6 works both times, then it is the solution, or is a solution. So what we're going to do is we're going to zoom out, and we're going to go to way over here, and we're going to put x plus y equals 7. And then we're going to replace 1 for x and 6 for y. So 1 plus 6. And does 1 plus 6 equal 7? Yep. So that means 1, 6 is true for the first line. Remember, these represent lines that are on the graph here. For example, I mean, you can imagine 1 x plus y, it might represent, I don't know, some line going like this. And then I want you to think that, imagine that 4x plus 3y equals 22 represents another line going like this. And what are we doing? We're supposed to be looking for the solution, the place where both lines work, all right, where the lines cross. And so what we've done is we've figured out so far that 1, 6 works for that first line. So let's see if it works for the second line. So you've got 4x plus 3y equals 22. And we want to see if 1, 6 works. So that means it's going to be 4 times 1 plus 3 times 6. And we want to see if that answer equals 22. So 4 times 1 is 4, plus 3 times 6 is 18. 4 plus 18 is 22. Woohoo! That equals the 22 that we wanted. So that tells us that 1, 6 works for both equations. It makes both equations true. So that means 1, 6 is, so I'm going to put yes, it is a solution of the system. Now let's verify that 2, 5 does not work. So let's see. So again, we've got the x plus y, and that equals 7. And then we've got the 4x plus 3y equals 22. So we've got the 4x plus 3y equals 22. And I need to scooch those around to make sure we've got plenty of room. And since the point, remember, the point is 2, 5. So what that's saying is we're going to replace the x with 2. We're going to replace the y with 5. 2 plus 5, is equal to 7. And sure enough, that works. Woohoo! That's a true statement. But in order for 2, 5 to work, it's got to work in both lines. So down here, it's going to be 4 times 2 plus 3 times 5. 4 times 2 is 8. 3 times 5 is 15. That gives us 23, and 23 does not equal 22. So what does that say? So that says that 2, 5 works for the first line, but it does not work for the second line. So that tells us that this is a big old fat no, because it does not work in both lines. We've got another example. We've got two different lines here, and we've got the values. So what I'm going to do is I'm going to zoom in a little bit here, and I'm going to write, okay, we need 2y is equal to 6x plus 8. And then we have to have the second one, so that's going to be 3x minus y equals negative 4. And so we've got our two lines. And so what we're going to do is we're going to zoom out, and I'm going to move those points over here. We're actually going to need them twice. So let's just make them twice. And we're going to need them twice because we're going to do it once for A and then again for B. So let's move these guys a little bit over. All right, so now let's take a look at negative 4, negative 8. So that means x is supposed to be negative 4 and y is supposed to be negative 8. So let's see if that works in both of these lines. So y is supposed to be negative 8. I'm going to shrink that down a little bit here. All right, so let's see. 2 and y is really negative 8. So that's 2 times negative 8. And this is 6 times negative 4 plus 8. So we know that the left side is negative 16. Let's see what the right side is equal to. So it's negative 24 plus 8. Hey, that's negative 16. So sure enough, that's a true statement. Woohoo! So I'm going to put a smiley face. But let's see if it works down here. So I'm going to bring this guy down here. And so remember, x is negative 4, y is negative 8. So that's going to be 3 times negative 4 minus negative 8 equals negative 4. And we're going to see if that works. So this becomes negative 12 plus 8. And negative 12 plus 8 is negative 4, and that works. And so, because negative 4, negative 8 works in both lines, it works in both cases, that automatically tells us that this is a yes. It is indeed a solution. So now we're going to do the same thing for 0, negative 4. So we're going to move over here, we're going to zoom in, and we're going to do 0, negative 4. So that means x is 0 and y is negative 4. So that becomes 2 times negative 4 equals, this becomes 6 times 0 plus 8. So the left side is negative 8, and the right side is just positive 8. So that's a no-go. It's wrong. It doesn't match. So automatically, we don't even have to waste our time with this guy because it doesn't matter one bit if it works because it's got to work on both of them. So what does that say? That says that this guy is a big fat no. He is not a solution. All right, we've got more of the same. So we've got 2x minus y equals 8. And then our other line is x plus 3y equals 11. And we know that we're going to need those twice, so I'll just kind of make 2 copies. And we're going to move over here, and we're going to need both of these. And we're going to need them twice because they want us to find out whether one or both, or neither, I suppose, of these problems are a solution for that line. So that basically means, does that point, and in this case, let's do 6, 4. All right, so we're going to move 6, 4 over there, and we want to know, does 6, 4 work for this line and this line? All right, So let's do the work. Sorry. So that becomes 2 times 6 minus 4. So that becomes 12 minus 4, which is 8. And sure enough, that works. That's a good thing. But that doesn't mean anything yet, because we got to make sure that 6 comma 4 also works down here with this line. So that becomes 6 plus 3 times 4. Well, that's 12 plus 6, which is 18. Uh-oh, that does not work. So automatically, that tells us that that 6 comma 4 is a big fat no. That does not work. So let's see if 5 comma 2 works. 5 comma 2, got to move that over here, and we're going to see if 5 comma 2 works for both of these lines. So first thing we're going to do is we're going to substitute 2 parenthesis 5 minus 2. Well, 2 times 5 is 10 minus 2, that gives us 8. So that works, but that doesn't mean anything yet, because 5 comma 2 also has to work down here. So we've got 5 plus, and then this is going to be 3 times 2, so that's 6 plus 5 equals 11. And sure enough, that works both times. It worked up here, and it worked down here. So that means 5 comma 2 is a yes. So this is a yes. It does work in both lines. This is the exact same. The only thing is they're kind of asking it in a slightly different order. They want us to know which of these two ordered pairs is a solution for this system of equations. So we're going to need to write both of these equations twice. And then the other one is right here, which is 5x plus 9y equals 15. So we have these 2 points, and or 2 lines, and we want them twice. So we got one here, one here. Let's create a little bit more space. And then we've got one here, and we've got one here. And we want to see if 3, 0, in this case, 3, 0 works. And then we want to see if negative 4, negative 7 works. So let's start by moving over that 3, 0, and then we're also going to move over that negative 4, negative 7. But let's start with the 3, 0. So we're going to substitute in. So that becomes negative 2 times 3 plus 2 times 0. So that ends up being negative 6 plus nothing equals negative 6. So that is a smiley face. That works. But let's see if 3, 0 works down here. So that becomes 5 times 3 plus 9 times 0. So that becomes 15 plus 0, which is 15. And sure enough, that works. So that's a smiley face. Since 3 comma 0 works in both of these, that tells us that 3 comma 0 is a yes. It is a solution. Well, let's see if negative 4, negative 7 is also a solution. So here's our point, and we're going to substitute negative 2 times negative 4 plus 2 times negative 7. So this becomes positive 8 plus, and this ends up being negative 14, which indeed equals negative 6. So that works. That's a smiley face. So now we got to see if negative 4, negative 7 works down here. And we're going to we're going to do a little substitution. And that becomes 5 times negative 4 plus 9 times negative 7. So that ends up being negative 20 plus negative 63. Well, that ends up being negative 83. That definitely does not work. So what does that tell us about negative 4, negative 7? That tells us that negative 4, negative 7 is a big old fat no. And the last problem for this video, same exact concept. We've got two lines, and we want to know which of these ordered pairs is a solution for our two lines. So we need to know if this point, any one of these points, works in both lines. So what does that mean? Well, that means we need to have both of those problems, both of these lines, we need them written twice because they have 2 points that they want us to check. All right, and so here's our two lines, and we're going to duplicate them. And we've got one right here, and then a repeat right there, and a repeat right there. And we want to know, does negative 4, 0 work? So does negative 4, 0 work in both of these lines? Negative 4, 0. So let's find out. Let's get this out of the way a little bit. All right, so let's find out. So that's going to be negative 4 equals negative 4 minus 4 times 0. This equals 0, so you end up with negative 4 minus 0 equals negative 4. Hey, look at that. That's a true statement. Negative 4 equals negative 4. So that is a smiley face. That definitely works. So now we need to check it down here. So this becomes 6 times negative 4 minus 0. Well, that's negative 24, and sure enough, negative 24 equals negative 24. So that is a smiley face. So that means negative 4 comma 0 works both times. So that is a yes. It is a solution. So now we've got to find out, fractions, but we could do it. I know we can. So that's 1/2 and 9/8. And we need to know, does this work for both lines? All right, so we're going to copy that twice. We're going to zoom over here. And we're going to move this here. And we're going to move this here because we want to make sure it works for both lines. All right, give us a little bit of room. So this becomes negative 4 equals 1/2 minus 4 over 1 times 9 over 8. So 4 over 1 times 9 over 8, we see that the 4 and the 8 cancel, so that is a 1 and a 2. And so we end up with 1/2 minus 9 over 2. And 1/2 minus 9 over 2, 1 over 2 minus 9 over 2, that equals negative 8 over 2, which is negative 4. So that tells us that this works. It's a smiley face. So now we got to see, does it work for this second line? And see, it's got to work for both lines. So we're going to do, let's see, this becomes 6 over 1 times 1/2 minus 9/8. And so now we're going to multiply. So this becomes 6 over 2 minus 9 over 8. So we're going to multiply both the numerator and the denominator by 4 so that we get a common denominator. So that gives us 24 over 8 minus 9 over 8. And when we subtract 24 minus 9, you end up with 15 over 8. And 15 over 8 does not equal 24. So that does, or negative 24. So that doesn't work. So that's a frowny face. That definitely doesn't work. So what does that say? That says that 1/2, 9/8, 1/2 and 9/8. That's a big old fat no. And so that's how you figure out if a line or a point is a solution for the system, because it's got to work in both lines.